Okay, so today we're going to start talking about quadratic functions. So far in Algebra 1, all we've talked about is linear functions, but now we're going to start talking about a different type of function, which is quadratics, which we've kind of started looking at with the whole x squared stuff. Okay, so we're going to fill in the top part, and then you're going to graph some stuff in your graphing calculator and kind of see what happens to these functions. So graphs that share the same basic characteristics form a family of functions. So all linear equations form a family. All lines are in the linear family. Okay, all quadratics are in the quadratic family. So all quadratic functions form a family because their graphs are all parabolas. Okay? Now, a parabola is a U-shaped graph. Okay, this is an example right here. So we have this U shape. Okay, notice it's not a V shape. A V shape is a different function. It's a U shape. It is curved here at the bottom. It's not a straight line that just turns and goes up. Okay, it is curved. That's called a parabola. Okay, so right here, these 2 points, we call these symmetric points. Okay, because from the middle, if I would break this graph in half, they're symmetric from the middle of that parabola. Okay, so this one's centered on the axis, but see if I go over 2, up 1, I get that point, and if I go over 2, up 1 this way, I get that point. So they're symmetric points because they're on the same part of the parabola but on different sides. Okay, this point right here at the very bottom, or it could be at the very top if it's an upside down U, is called the vertex. Okay, the vertex is the only one that doesn't have a symmetric point because there's only one of these. Okay, this line going down the middle, it's kind of hard to see on your paper. It's a dotted line right here. The line that breaks the parabola in half and makes it symmetric, that's called the axis of symmetry. Okay, that's the line that cuts it in half to make it symmetric on both sides. Okay, standard form of a quadratic. So y equals ax squared plus bx plus c. That's for a quadratic. Remember, for linear, just a refresher, linear, it was y equals ax plus by equals c. Alright, that was linear. I'm just kidding. This is not, that wasn't standard form. Okay. mx plus b was our linear. This one is our quadratic. Okay? A, b, and c are real numbers. Basically just any number that we've talked about. A cannot be 0. If a is 0, that means it's a linear function because there is no x squared. This would be gone, and it would just be bx plus c. Okay, the parent function of a parabola, just y equals x squared. Okay, in other words, there's just a 1 in front of the x squared, and then a 0 in front of the x, and a 0 for the c. Okay, which just comes down to this. Remember, for a linear function, it's y equals x. Okay, so the only difference between a parent function for a linear is this little squared right here. The squared makes the U shape. Okay, the x, just an x by itself, would make just a straight line. Okay, so that's the intro to characteristics for quadratics. Now, we're going to go down here and use our calculator. So it says input the parent function in y1. So get out your calculator. Okay, so I'm going to y equals, and I'm going to put x squared, my parent function, into y1. Okay, graph it. Okay, so I get this parabola. My vertex is at 0, 0. And my axis of symmetry is this y-axis. Goes right down the middle. Okay, so now input x squared plus 5 into y2. So keep that x squared in there. Now do x squared plus 5. Okay, graph. So there's my original. Now what happened to my new graph? This one right here is the x squared plus 5. So it can either get wider or narrower, or it can shift up or shift down. So it looks like it might be narrower because it's inside this other one, but don't get that confused with being shifted up and shifted down. They're actually the same size, but this new one was shifted up 5 units. So down here when I describe what happened, I'm going to say it shifted up 5 units. Okay, now it says put x squared minus 8 into y2. Oops. Okay, so again, keep your x squared in y1, that's your parent function, and then put x squared minus 8 into your y2 graph. Again, there's my original. Now there's my new one, the x squared minus 8. So here, you can kind of see it just took this and it moved it down. Okay, so this one shifted down 8 units. Okay, and I want you to be specific, not just moved up, moved down. I want you to use the word shifted, and I want you to tell me how much it shifted, up or down. Okay, I'll do one more with you. So, this one says keep the parent function in y1 as you answer the rest of the question. So we'll go ahead and clear out y2, and let's just look at the graph of y1, which is just the parent function. Okay, what is the parent function's vertex? Okay, if I go back to my drawing, the vertex is this point right here at the bottom of the U. Or if the U is upside down, it'd be at the top of the U. Okay, so that's the vertex. So if I'm looking at my calculator, that vertex is right here where it switches from decreasing to increasing, and that point is 0, 0. So the parent function's vertex is always 0, 0. Now, the axis of symmetry, we kind of already talked about this, goes right through the middle and cuts that parabola in half. So here, it's going to be the y-axis. Well, what is the equation for the y-axis? First of all, it's a vertical line. So all vertical lines start with x equals. Okay, and what is x for this whole line? Well, it's 0. Okay, your axis of symmetry will always be x equals something. Always. That won't ever change. It's always going to be x equals something. You just have to figure out what x value cuts that in half. Okay, so now you're going to practice putting some different functions into your calculator. Tell me how it changed. Tell me the vertex of the new graph as an ordered pair, x comma y, just like I did up here. Okay, tell me the axis of symmetry, just like I did up here, as an equation, x equals something. And then I want you to tell me a symmetric point to 311, so, or whatever the one's given. So up here, if this is 2 comma 1, if I gave you that and said, what's the symmetric point? You would just go right over here and say, well, the one symmetric to that is -2, +1. So the symmetric points have the same y value, but different x values. Okay? So you're going to go ahead and finish up that entire packet, and you'll take a post-assessment at the end of class. And I will see you on Wednesday.